Okay, welcome back to the class. So today I want to talk about 4-variable kmaps. Okay, so here's an example. The first thing that you want to do here is to actually fill in the kmap. So that's kind of an exercise. You have to remind yourself of how the values get transferred from sort of the function to the kmap. So maybe you want to write down the truth table. Maybe you can immediately read it off. In any case, I'm going to just give you the solution, but I recommend that you actually try it yourself. So in this particular case, I have 0, 1, 1, 1, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 1. And again, convince yourself that that makes sense to you and that you agree. Okay, then the next thing to do is to actually minimize this function, which again you're going to do by essentially drawing circles around the ones, around the onset, and you're going to try to make these circles as large as possible. You have to cover all the ones, and then you can read off the value of these circles and OR them together, and that will essentially give you the minimal function that you're looking for. So in this particular case, the first circle I see is essentially, let me see, this one here, right? And that's a circle that's essentially crosses all the boundaries except that it's within D equals true. So you can say that this here is equal to D, or, and now you have to do something with these other ones here. And again, this is where it's a little tricky. So again, you can reuse the same one. Actually, you want to do that, so you can make this circle expanded sort of upwards from here. All circles have to have power of 2. So you can't make a circle around all 3 of these here. And again, like kmaps wrap around the edges, so they're sort of more cylinders or spheres in a sense than these sort of flat maps. So in this particular case, you can draw a circle that looks something like this. It's within C and not B, and it crosses the A and B boundary. So this is C and not B. Okay? So again, circles can wrap around edges. Okay, but you can already see the power of this tool. I mean, without really thinking at all, you were able to get this minimal function, and without essentially doing too much work, you were able to minimize this function. Okay, so here's another example. Okay, so first step is to actually fill in the kmap. So I'm just going to spell this out. This is A not C D, or not A C D, or A not C not D, or not A B C not D. Just spelling out the XOR. I'm going to draw my kmap here. And again, stop the video, do it yourself. This is going to be useful exercise. Okay, so you have to remember A goes here, A is true here, D is true here, B is true here, C is true in these columns. Then, whichever way you like, you have to kind of fill in these cells. And you should get this 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0. Okay, what circles do you have? Well, there's one up here that nicely covers these 4 ones. There's one here. There's another one here. And I think that's sort of the biggest circles that I can do. I don't need any more. I've covered all the ones. So this is A not C. This here is C, D, not A, C, D. And this one here is, what is it? Not A, B, C. So the function here is equal to A not C or not A, C, D or not A, B, C. Okay? So again, that's a pretty easy way of minimizing a potentially complicated function. Okay, so now there's another sort of little wrinkle here, is that sometimes you can actually have kmaps that have multiple equally good solutions. So equally good here meaning equally compact. Okay, so let's look at this particular kmap here. Again, you can draw a range of circles. So up here, let me start with this one here. There's also a circle down here that seems, potentially useful. So this circle up here is, it's the only or largest one that covers this particular one. This is the largest one that covers this particular one. Now I just have to do something about this one here that's part of neither of these two circles. And you could do this by drawing this circle. We could also do it by drawing this circle. And either of these solutions is perfectly correct. So in fact, in an exam or in a quiz, you might actually want to provide both of these solutions. So that the total solution here, let me switch back color. So this circle up here is not A, not C. This one down here is A, C. And then the other two circles here, this one is C, B, C, D. And this one here is B, not A, B, D. So the overall function you could write down is something like F is equal to not A, not C, or AC, or I'm going to use these curly brackets here, not A, B, D, B, C, D. So either of these two expressions is correct and is a minimal solution of that kmap. So just as for practice, let's do one design example using kmaps. So this is the goal of this example is to design a 2-bit adder circuit, which is actually a useful circuit that we'll encounter again later. So what we want to do is we have two 2-bit numbers that are the inputs. So AB is a number and CD is another 2-bit number. And then the output is essentially just the sum in binary of these two numbers. Okay. So, and we want to design the circuit that actually realizes sort of this particular set of truth tables. So if we have a problem like this, you can look at the left-hand side here. And that gives you the kmap size. So it's a 4-variable kmap. And the right-hand side here tells you kind of how many kmaps you will need. Okay, so in this particular case, you have 3 kmaps for each of these outputs X, Y, and Z. You'll have to design its own circuit. This is just a compact notation for essentially specifying 3 independent truth tables. Okay. So let's quickly do this. I'm going to draw this very quickly, but as always, I would recommend that you stop and do it yourself, just as practice, because this is going to be helpful. But let me quickly solve that for you, just so you have the solution. So I have 3 circles here. Okay. And the corresponding function is AC, that's the big circle, or ABD, or BCD. Okay. Here I have the following circle, so I have one up here, I need for this one. I have another one here, I need for this one. I have one here, this one here, and then these 2 ones, there's not a whole lot I can do, so I just have to circle them individually. And if you read off this function, it's actually kind of inconvenient. It's A, B, C, D, so that's one of the small circles, the 1x1 circles, or not A, B, not C, D, or A, not C, not D, or not A, C, not D, or A, not B, C, or A, not B, not C. So the sad truth is that sometimes some functions just can't be simplified very much. Then the last one here for Z. So this is one of the trickier ones, right? So you have to remember that these circles can wrap around. So you have 2 circles here that wrap, and that's really all you have. And what this is, it's not B and D, or B and not D, which of course is B XOR D. Good. Okay. Very good. So I think now you're exhausted of seeing all these kmaps, and hopefully by now this is really easy for you. If not, again, just practice with the examples in this lecture or read the book.